I didn't have to attend Hogwarts or use the Force to learn how to move this straw. If you want to channel your inner 11, all you need is the magic of science and a few things at home.
If you've ever felt this thing as static electricity but didn't know why,
Like when you get zapped, take off a knit sweater, or just see your hair floating up around you,
we'll explain it all.
you're sure to shock your family and friends with these cool activities you can just try at home.
For this activity, you'll need a plastic straw, a cloth or towel, and any type of plastic water bottle.
To create static electricity, just rub the towel against the straw, then balance it on top of your water bottle, and use your hand. The straw should follow your lead. The straw should have followed your hand without you even touching it, all thanks to static electricity.
Wait, what even is static electricity?
Static electricity means non-moving electricity, and it stems from the imbalance of electrical charge. This imbalance is caused by the movement of negatively charged particles, electrons. Since the straw and the towel were in such close proximity with each other, electrons from the towel transferred to the straw, making the straw negatively charged.
And basically, this transfer of electrons is called the Triboelectric Effect.
The negatively charged straw was attracted to the positive charges in our fingers, basically following its lead. Ever heard the phrase opposites attract?
This Triboelectric effect may also be the reason behind why you may feel a shock when you touch another surface, especially a metal surface.
Have you ever been zapped when going down a slide? That comes from the rapid movement of electrons as you transfer from the metal to your skin. You can also observe the effect of static electricity in the soda can activity. You will need an aluminum can, a towel or a cloth, and a balloon. So like we did before, we just have to generate static electricity using our towel by rubbing it.
And this time around, for this activity, you can actually rub the balloon against your hair.
You just have to lay our can flat, and the balloon should move the can.
And basically what's happening here is the same as the previous experiment, and the balloon is negatively charged because of a transference of electrons from the towel or the hair.
Here's another cool example you can try. You just need small pieces of paper. I use a hole puncher to create little circles, a cloth or towel, and a balloon. So you want to do the same thing as we did in our last activity. Rub the balloon with your towel to create static electricity, same transferring of electrons, and then just hold it over your small pieces of paper and see what happens. Again, our balloon is becoming negatively charged, and it is attracted to the positive charges in the paper, and the paper sort of flies up towards it. So you may be wondering why we've been using a towel for most of our activities. Why doesn't the towel gain electrons instead of the balloon? Well, some materials are better at receiving electrons, like our balloon, our plastic spoon, and our straw, while others, like our hair, our towel, are better at giving away electrons. And there's actually a way to tell. There's a list called the Triboelectric Series, which ranks materials by its tendency to gain or lose. Try experimenting with these different materials to see what effect they have on each other.
If you ever think that the salt and pepper mixture for your food is a little too spicy, you may be able to solve that with this trick.
For this activity, you will need a salt and pepper mixture in a 1-to-1 ratio, a plastic spoon, a white sheet of paper, or any surface, and again your cloth or towel. So you want to start by generating the static electricity, again initiating the Triboelectric effect by rubbing the spoon against your towel, then pour your mixture out onto the plate. Then, after charging up your spoon, you can just run it over the salt and pepper mixture and see what happens. The pepper should fly up onto the spoon.
So you may be wondering why it's only the pepper that goes to the spoon and not the salt after that activity.
Salt is actually attracted to the spoon, but not nearly as much as pepper, because pepper has a stronger positive charge.
Pepper is also far lighter than the salt, so it'll fly up to the spoon more easily.
But try to look close into your spoon and see if there are any salt particles as well.
One spark of static electricity can measure up to thousands of volts. Static electricity can also be useful around the household for cleaning dust and air freshening. Be sure to try these activities out at home, guys.
I hope we shocked you in more ways than one.